A network is only as good as the data we feed it, and real data needs a little plumbing to get in. In this lesson we'll meet 3 tools that handle that plumbing: the dataset, the transform, and the DataLoader. We'll use real images the whole way through. Our data is fashion mist, 70,000 tiny grayscale photos of clothing, sorted into 10 classes. Here's one real example from each class: a t-shirt, a trouser, a pullover, and so on, down to an ankle boot. Every image is just 28 by 28 pixels. The first tool is the dataset. Think of it as a numbered list. Ask for item 0, and it hands you back a pair. The pair is an image and its label. Here, image number 0 is this ankle boot, and its label is the number 9, the class code for ankle boot. Every item is one image, one answer. But a network can't see a picture, it only understands numbers. So what is an image, really? Let's zoom right in on a patch of this one. Each pixel is just a brightness value, from 0 for black up to 255 for white. Line them up and the image is nothing but a grid of numbers, 28 across, 28 down. The second tool is the transform, and its job is to prepare those numbers. The main step is called to tensor. It simply divides every pixel by 255, squeezing the range down to 0.0 through 1.0. So 255 becomes 1, and, say, 128 becomes about 1/2. Networks learn far better on small, tidy numbers like these than on raw values up to 255. Before training, we split the data in two. Watch the counts climb. 60,000 images go into the training set, the ones the network learns from. 10,000 are held back as the test set. The test set is never, ever trained on. It's kept sealed, so that later it can give us an honest measure of how well the network really does on images it has never seen. 60,000 images is far too many to push through at once, so the third tool, the DataLoader, hands them over in small groups called mini-batches. First it shuffles the whole pile, so the order is random. Then it scoops out a batch, say 64 images, and passes just those to the network. It repeats until every image has been used once. That's one epoch. Shuffling each time stops the network from memorizing the order. In PyTorch, these 3 tools are just a few lines. Fashion mist is the dataset, and we hand it our transform. Then we wrap it in a DataLoader, asking for a batch size of 64 and shuffling switched on. From here, we can simply loop over the loader, batch by batch. So, the data pipeline in 3 tools. The dataset returns an image and its label by index. The transform turns that image into a tidy tensor of numbers. And the DataLoader shuffles everything and serves it in mini-batches, holding a sealed test set aside. With clean data flowing in, the network is finally ready to train.